All right, this is lesson 5.5, more optimization, part 2. Example 4, the figure below represents a square sheet of cardboard with side length 20 inches. So the outer shape here is a square, and it is 20 inches by 20 inches before we cut out parts of it. The sheet is cut and pieces are discarded. When the cardboard is folded, it becomes a rectangular box with a lid. So you can see these edges would fold up, lift it up, fold it in, and then this is the lid that closes on the top. And so we get this little box. I don't normally draw my three-dimensional figures this way. And then it has the lid on the top. So we get that little three-dimensional little box. Just about like that. There we go. All right. Let's see. The pattern for the rectangular box with a lid is shaded. So that's the shaded figure there. 4 squares with side length X and 2 rectangular regions are discarded from the cardboard. Which of the following statements is true? It says the box has a minimum possible volume, maximum possible volume. So we're looking at the volume of this box. So we really need to be able to write an equation for the volume of this box. I know that we're taking out this material in white, and these are little squares that we're removing. So this is also length X here. Now, if the whole side started with 20, then what is this little piece? 20 minus 2x. Very good. We're subtracting 1x and subtracting another x, and the leftover material would be what we started with, the whole, minus the pieces we removed. So minus the 2x. So that one's not so hard. So we know this is also length x here. But what is this piece? Well, because it's a lid to the box, this length and this length must be the same. They must be the same size. We don't want a lid that comes up short here. So it does have to be the same length. The top has to be same length as this. Now, if it was 20 take away 2x, then these are congruent parts. So it really would just be 20 minus 2x divided into 2 equal pieces. Does that make sense? I hope that makes sense. And that also reduces. And so what we have then for the box is we have this longer side, which would be 20 minus 2x. And then this little width piece would be 20 minus 2x over 2, which everything divides by 2. So that'd be 10 minus x. And then the height of the box is just x. And so we can use that to write our volume equation, because 10, we're going to have x for the height times the width, 10 minus x times that length, 20 minus 2x. Okay, fantastic. I'm going to go ahead and distribute in my x and then multiply this all together. So 10x minus x squared. And then I'm going to FOIL these together. Now, go ahead and multiply this out and combine like terms, and then go ahead and take your derivative and find your critical numbers. I'm going to pause the video while you do that. You should pause the video also. All right, so I got my volume function, and then I took my derivative and was able to factor it, and I come up with these x values, and let's talk about these x values. Specifically, x equals 10. Can x equal 10? If x is 10 and this x is 10, would there be any shaded material here? No. X absolutely must be less than 10. much less than 10, in fact. And so this is not even a possible number. X definitely had to be less than 10 for this to have any volume at all. So 10 thirds, let's see, I'm going to go ahead and do my little V prime sign chart here. 10 thirds is, let's see, 3 1/3. Is that right? 3, yeah. So I'm going to go and I'm just going to try 1. So if I plug in a 1 to this equation, that would be a 3 minus 10, that'd be a negative and a negative. Negative times negative would give me a positive result. And a number to the right of 3 1/3 might be like 5. So plugging in a 5, 15 minus 10 is a positive result, and 5 minus 10 is a negative result. Positive times negative is negative. So it looks like we're going from increasing to decreasing, which makes this a maximum point for the volume. So we have a maximum when X is 10 thirds, maximum volume. Okay. I thought this is a good problem. Okay, this one looks super complicated, but they actually give you everything you need, so it doesn't turn out to be quite so bad. The figure above, well, rather below, I did some rearranging, shows a rectangle inscribed in a semicircle of radius 2. So this is the radius of 2 for that circle, semicircle. The area of such a rectangle is given by this formula. And that is the whole area. You'll notice that it's 2x because that's one side is x and the other side would x. So they're doubling it. They're taking the square x times base times height. So that's the x times that square root function there. That gives you that y value. And then they're doubling it. So that's where the 2 comes in. That's going to be really necessary second semester. Where the width of the rectangle is 2x. Now, it can be shown that A prime, they're giving us the area function. They're also giving us the derivative. Crazy derivative here, right? But hey, we don't have to do it. They've given it to us. They've also told us that we have the critical values. That's nice. So I don't have to solve this. All the critical numbers were given to us. That's nice. It can also be shown that A prime of x, so the derivative changes from positive to negative. Oh, my pen just died. Positive to negative at square root of 2. Positive to negative. Well, if the derivative is changing from positive to negative, that is a maximum value. And so it looks like we would have a maximum area. This is critical number x. So if x equals radical 2, we want to know what are the dimensions. And this is the tricky part. So what are, whoops, I meant to underline that one. What are the dimensions then of that inscribed rectangle? All right, well, let's figure that out. The width of the rectangle is 2x. So that means if we want to find the width, so this would be another x and then times x, or x plus x rather. So radical 2, and there are 2 of them, so 2 radical 2 for the width. And then the length, this is the square root of 4 minus x squared. That's going to give me the length. So if I plug in my square root of 2 and I square that, radical 2 squared is 2. And so we just get radical 2. So these are the dimensions. 2 radical 2 by radical 2. And I missed that the first time. I just gave them the dimensions of the square, which is this, not the rectangle. Tricky. Ladies and gentlemen, that is your notes for today. Again, your assignment is in AP Classroom. And take your time with it. Really try and figure those out. They're interesting questions. Have a good day.